Welcome to lesson 1.3. Today's lesson is on function notation. The symbol f of x, where you see the f and then the parentheses and the x inside the parentheses, is read just as I said it, f of x. This notation is attributed to Leonhard Euler. His last name is spelled E-U-L-E-R, but is pronounced Euler. In 1770, Euler wrote what is considered the most influential algebra book of all time. It was the Complete Introduction to Algebra. In honor of him, f of x is also called Euler's notation. So a lot of times you'll see it either way in a math book, as Euler's notation or f of x. When writing in function notation, what is written in the parentheses is called the argument of the notation. The result is called the value of the notation, or the value of the function. So if we would do that as an example, if you have f of x, what's inside the parentheses, that x, would be the argument. It's the name for it. And the result, when you figure this all out, would be called the value. And we'll do an example so you can see that. Okay, example 1a, it says if t of c, so instead of saying f of x, I'm going to say t of c, because that's c's in the parentheses, that's how you pronounce it. If t of c equals 1.8c plus 32, we're going to evaluate t of 20. So we're going to plug 20 in for c, that's what it's saying. So what's inside that parentheses, that c, they're telling us to put a 20 in for that. So we're going to say t of 20 equals 1.8 times 20 plus 32. So wherever you would see a c, you would plug in 20. We can solve that. 1.8 times 20, because we're working left to right, is 36, plus 32 equals 68. Our result, or our value of the notation of that function, is 68. And the argument in this case is 20. In example 1b, if t of f equals 5/9 f minus 32, evaluate t of 86. So they're saying if we're going to plug in t of 86, so 86 in for f, wherever you see an f, you're going to put an 86. So we're going to evaluate that t of 86. And we'll say t of 86 equals 5/9. We got to take care of what's inside the parentheses first. 86 minus 32 equals 54. And 5/9 of 54, we'll divide that, the 54 by 9, and get 6. 5 times 6 equals 30. So the t of 86 equals 30. This formula is actually a conversion formula for how to go from Fahrenheit to Celsius. So they're saying if the temperature is 86 degrees Celsius, that t of 86, what would that be in, I'm sorry, if that's the temperature 86 degrees in Fahrenheit, what would that be in Celsius? It would actually be 30 degrees Celsius. So that's just an interesting little fact. That's how you would convert from Fahrenheit to Celsius. Okay, next we're going to talk about mapping notations. So there are mapping notations for functions. Mapping notations use a colon and an arrow. The function from 1a could be written in mapping notation as follows. So I'll rewrite that function from 1a so you can see it. It was t of c equals 1.8c plus 32. That was the function notation in 1a. We're going to rewrite it as a mapping notation. So instead of a parentheses, we're going to use a colon. So we're going to say f of x, and then instead of an equals, we're going to use an arrow. equals 1.8c plus 32. That's a mapping notation. It just substitutes the colon or the parentheses for the colon and then the equal sign for the arrow. And this is read, the function f maps c onto 1.8c plus 32. For f of 20 equals 68, in mapping notation we would write f of 20, and that value would be 68. So that's how we would write it in mapping notation instead of that other way where it was t of 20 equals 68 or f of 20 equals 68. We can write it that f and then the colon 20 maps onto 68 and the value is 68. So that is mapping notation. Okay, let's do two example problems. Example 2a, it says let f of x equal the square root of 5 squared minus x squared, and evaluate f of 3 and f of r minus f of 3. So we're going to plug, they're saying put 3 in for x. So we're going to say f of 3 equals, and we're going to do 5 squared minus 3 squared, because wherever there's an x we put that 3 value. That's what they're saying that we need to do. So f of 3, 5 squared is 25 minus 3 squared is 9. And then f of 3, 25 minus 9 is 16. Square root of 16 equals 4. So f of 3 equals 4. The value of the function is 4. Now they want to do something a little different. They want to do f of r minus f of 3. So we're going to plug r in for x wherever we see x. So f of r equals, we still have that same function, 5 squared minus x squared. So let's put in r wherever we see x. I know it seems kind of strange to do that instead of doing numbers, but this works as well. We can say 5 squared minus r squared. We can clean that up a little bit, and we can say f of r equals 25 minus r squared. Without knowing what r is, that's all the further we can go with that. But they want us to do f of r minus f of 3. So f of r minus f of 3. Oh. Okay, let me fix that. It was f of 3. I had the wrong thing in the parentheses there. That equals, so we know f of r, we just said, was square root of 25 minus r squared, and they want to say minus f of 3, and we know f of 3 is 4. So f of r minus f of 3 would be 25 minus r squared, take the square root of that, minus 4. And that's all the more you can do with that one. In example 2b, it says f of x, we map f of x onto x plus x squared over 20. And they want us to evaluate it at f of 10 and f of s plus f of 10. So similar problem to 2a. So f of 10, we're going to plug in 10 for all the x's, so we have 10 plus 10 squared over 20. And this time there's 2 x's in that function. F of 10 equals 10 plus 100 over 20. F of 10 equals 10 plus 5 equals 15. So f of 10 equals 15. So that's the first answer. Then they want to evaluate at f of s plus f of 10. So we're going to do f of s, we got to evaluate that first. So we're going to plug in s's for x's. So in that function we're going to say we have s squared plus s squared over 20. So we're plugging in all the s's for x's. So f of s, oh, I apologize, actually This is not an s squared. Let's erase that, because it was not an x squared. So it should have been an x. And in this case it's an s. That probably makes sense. So f of s equals s plus s squared over 20. That's all the more you can do with that f of s. But they want f of s plus f of 10. So we're just going to combine the two here. So we have f of s, we say, is s plus s squared over 20. And then f of 10 is 15. So f of s plus f of 10 is s plus s squared over 20 plus 15.